Europa, one of Jupiter's moons, is characterized by an icy crust that envelops a liquid water ocean, making it one of the most fascinating places in our solar system to search for signs of life beyond Earth. This moon is often at the center of scientific speculation due to its potential to host life, as water is considered a fundamental ingredient for life as we know it. To delve deeper into the mysteries of this extraordinary icy world, NASA is preparing to launch the Europa Clipper mission, a probe dedicated to thoroughly exploring Europa. Today, we will explore everything there is to know about this mission and the significance of Europa in the context of astrobiology and planetary geology. The Europa Clipper mission represents the latest step in a long journey of exploring Jupiter's moons. Europa was discovered in 1609 by Galileo Galilei, who, by pointing his telescope toward the gas giant, revealed one of Jupiter's 4 largest moons. For centuries, Europa remained just a bright point in the sky, until space missions allowed us to examine it more closely. The first probes to reach Jupiter were Pioneer 10 and 11, sent in the early 1970s, providing the first close-up images of the planet and its moons. Later, in 1979, the Voyager probes made a significant leap in our understanding of Europa, revealing surprising features on its surface. Close-up exploration was truly undertaken by the Galileo probe, which orbited Jupiter between 1995 and 2003, gathering detailed data on Europa and its neighboring moons. Currently, the Juno probe, in orbit around Jupiter since 2016, continues to study the planet and its moons, while the Europa Clipper launch is scheduled for October 10, 2024. Why study Europa? Europa is slightly smaller than our moon, but stands out as one of the so-called ocean worlds. Beneath its thick ice crust, it is believed there is a liquid, potentially salty, water ocean. This feature makes Europa an extremely interesting candidate in the search for extraterrestrial life. Scientists hypothesize that Europa's ocean might provide the necessary conditions to support life, which is a key point of interest for astrobiologists. Europa's surface is primarily composed of water ice and has few craters, suggesting that the moon is geologically active. One of Europa's most intriguing features is the series of dark lines crossing its surface, resembling cracks. These could be the result of cryovolcanism, where icy material, heated by internal processes, rises to the surface, splitting the icy crust. Europa Clipper is an ambitious mission designed to explore Europa in depth. The idea for this mission emerged in the 1990s during the final phase of the Galileo mission, which conducted numerous close flybys of Europa. However, the Europa Clipper mission was officially selected and funded only in 2013. The probe will be launched from Cape Canaveral aboard a SpaceX Falcon Heavy rocket and will take several years to reach its target. After a flyby of Mars in 2025, the probe will head toward Jupiter, arriving in 2030. Europa Clipper will not directly orbit Europa due to Jupiter's intense radiation environment. Instead, it will perform around 44 flybys of the moon, some at incredibly close distances of just 25 kilometers, 15 miles, from its surface. This strategy will allow the collection of detailed data and high-resolution images of Europa's entire surface, providing an unprecedented view of its geological features and the possible interaction between the subsurface ocean and the icy crust. According to NASA, the primary objectives of Europa Clipper include determining the thickness of the ice crust. This is crucial because a thicker or thinner crust could affect the amount of light and heat reaching the underlying ocean, as well as the accessibility of potential life forms. Investigating ocean surface interaction. Europa may feature plumes of vapor rising from its surface. The mission will seek to understand how the ocean interacts with the crust and whether there are processes similar to those observed on other icy moons, like Enceladus. Studying the chemical composition of the ocean. Determining if fundamental chemical elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are present in the ocean is essential to assess the potential for a habitable environment. Analyzing geological structures. The mission will also focus on studying Europa's surface geological features, such as investigating whether there is plate tectonics. Europa Clipper will be equipped with 9 advanced scientific instruments to collect comprehensive data about Europa. These include high-resolution cameras, spectrometers for chemical and geological analysis, and tools for studying the dust and particles in Europa's atmosphere. In summary, the Europa Clipper mission represents a crucial step in our understanding of Europa and the potential for life beyond Earth. With its ambitious goals and state-of-the-art instruments, Europa Clipper will provide unprecedented insights into one of the most fascinating worlds in our solar system. The probe will not only help answer fundamental questions about Europa's geology and astrobiology, but also offer new perspectives on how we consider life in the universe. If you enjoyed this video and want to explore the topic further, we invite you to like and subscribe to the channel. Also, activate the notification bell to stay updated on upcoming content.